Alright, let's use this time to do some practice with factoring. And specifically, we'll focus on when factor by using the GCF. Okay, so there's another video about all these different methods and some examples, but we'll just do examples here. So the first example that I want to do, if I gave you 5x minus 35, I want you to factor using the GCF. Well, notice that you have two terms here, and then you ask yourself, what is the greatest common factor, GCF, between 5x and 35? Well, if I labeled the entire, if I look at the 5 and 35, they're just the numbers, the greatest common factor is 5. And notice how the first one has an x and the other one does not. So all I can factor out between 5x and 35 is 5, leaving me inside my parentheses 5 times what gives you that first term 5x? Well, that's just 5, which is x, sorry. And then if I take out that 5, then I'm left with, from the 35, if I factor out a 35, sorry, if I factor out a 5 from the 35, I'm left with 7. And because this was a negative here and I'm factoring out a positive, then this part should still stay negative. And as a quick recall about how to check, I could distribute the 5 into this. So then I get 5 times x is 5x, and 5 times that negative 7, you get negative 35. So when I think of the word factor, I also want to think about the distributive property essentially. Okay, let's try another one. If I give you, let's say, negative x squared minus 3x. Well, looking at this, they both have a negative, and especially this first term is negative. So I like to take out a negative 1 for that. I'll put a negative 1 like that. And then not only that, if I look at x squared and 3x, then the term that the factor that they have in common is just a single x here, leaving me with, well, if I take out a negative 1x from the negative x squared, I'm left with x. And then if I look at the fact that I took out a negative from the second term over here, then this should still be a positive. And then if I take out that, negative 1x times what gives you that negative 3x? Well, that would be 3. And then instead of writing negative 1x, I can write just negative x. So you have negative x times x plus 3. Now let's try another one of these. If I gave you 4x squared plus 4xy plus 12x. So notice that you have 3 terms, and so let's break it up into each of the parts. Let's look at the numbers. Well, this has a 4, this one has a 4, and this one has a 12 over here. So what's the GCF between 4, 4, and 12? Well, the answer to that is 4. Now, let's also look at the variables while we're at it. This one has an x squared, this one has an x and a y, and this one has an x. So what do all 3 of these have in common? At least one x to the power of 1. So the x, and then they each have at least x to the power of 1. And then let's look at the y's. They don't have any y's in common except for the middle term. So you have to check for all 3 of your terms. If I take out a 4x, if it helps you to not think the way that we've been doing it earlier, I could do this instead. Write down 4x squared plus 4xy plus 12x. And then whatever you decide to be your GCF, I'm going to divide by your GCF for each of those terms. Okay, and then I get 4x that's on the outside, and then 4x squared divided by 4x is just x, plus 4xy divided by 4x, I'm left with y, plus, because there's a plus sign there, 12x divided by 4x, 12 divided by 4 is 3, x divided by 3 is 1, leaving me with 3 times 1, which is just 3. So that's another way you can think about what is left inside. So remember, when you use the distributive property, you multiply, but factoring is kind of like doing the inverse process of that, which would be division. Okay? So now let's do factoring, some quick factoring. When the leading coefficient is 1, that is to say that when you have ax squared plus bx plus c, for example, when a equals 1. This is specific for like a quadratic, but I'm just trying to say that the leading coefficient here, that a, the one with the highest power exponent term, is 1. So, for example, if I did example number 4, we get x squared plus 11x plus 28. You can see that the leading coefficient here is that 1. So that's the example that we have here. Now I'm going to do this using factor by grouping method. So you have to identify your A, which is 1, your B, which is 11, and your C, which is 28. And then to do factor by grouping, you think about A times C, which is 1 times 28 is 28, and the B goes at the bottom, which is 11. You ask yourself, what two things multiply to 27 but add to 11? Well, so let me put multiply and then add. So that way you could think about it. So what two numbers multiply to 28 but add up to 11? Well, that is simply just 4 and 7, right? 4 times 7 is 28. 4 plus 7 is 11. So that part replaces this part, this middle term. So the original expression is going to state, that original expression is going to be equal to x squared, but instead of writing 11x, I'm going to write plus the 4x or 7x, it doesn't matter. I just need to pick one of them, plus the 7x. Notice how 4 and 7 are both positive, and these are like terms to get back your original 11x. That's why I wrote equals here. And don't forget the 28 that's in the back there. Now that you have 4 terms, I can factor by grouping. Okay, so I'm going to write factor by grouping as a reminder. Hence, the reason why I like this method is for the fact that all I do is the GCF. So what's the GCF from x squared and positive 4x? Well, we just practiced that. It's just x. So then I have x times x plus 4. That's what's left in the parentheses. Plus, because it's a plus sign here. What's the GCF between 7x and 28? Well, just a 7. And leaving me with x plus 4. So again, how many terms do I have now? Well, I have first term separated by this plus, and then this term. So what do these two terms have in common? What's the GCF here? Notice it's x times x plus 4 and 7 times x plus 4. So 7 is a factor for the second term as well as x plus 4. The first term has x for a factor as well as x plus 4 as a factor. So then what do they each have in common? The x plus 4. Leaving me, I like to put a bracket first with an x from the first term and then plus the 7 from the second term. And then the bracket can then be changed to a parenthesis in reality, because there wasn't anything more complicated than that. Okay? And then just as a quick double check, if I distribute the green for x plus 4 to the first term, I get back this part, that term right here. And if I distribute to the second term, I get x plus 4 times 7, which is the same thing as 7 times x plus 4. Okay? So that is our factored version. So for conclusion, for clarity right now, therefore, we get that, I had to scroll up, x squared plus 11x plus 28 is equal to x plus 4 times x plus 7. This is factored over here, factored form. So let's do some more examples of this, but if you think you got it, then I guess the other examples are not necessary. But I will do a little bit more of a difficult one towards the end of this. So let's try one. Example 5, x squared minus 9x plus 8. Leading coefficient you can see is 1. And so when I do that, I'm going to identify my A, which is 1, your B equals -9, and your C is 8. Grab my big X for organization purposes. A times C on top, that's 1 times 8 is 8. Little b at the bottom, which is -9. Two numbers multiplied to 8, but add up to -9. So if I did 8 and 1, right, they add up, they multiply to positive 8, but they do not add up to -9. But if I change both of them to a negative, then I get -8 times -1 is positive 8, but -8 plus -1 is -9, so this is good to go. So then when I do this, I'm going to rewrite -9x that's in the middle with these two pieces of information, which is -8x minus 1x. And then I'm going to copy my x squared that's already in the front and the 8 in the back. And this now is equal to this statement. Do the GCF, factor by grouping. So the GCF between x squared and -8x is x, leaving me with x minus 8. There's a negative sign here, so use a negative sign. And then what's the GCF between 1x and 8? Well, between 1 and 8, it's 1. And between x and no x is being involved, it's just 1. So really, you're pulling out a -1 from this, leaving me with x minus 8. Now, from here, you have two terms again. This term and this term, you have two terms. And so what's the GCF from those two? It is your x minus 8. They both share that, leaving you with an x from the first piece and a -1 from the second piece. And then again, brackets are not necessary in this case. I could just write it with parentheses. And there you have your factored form. Let's do one more of those, which is, let's do x squared plus 3x minus 10. And if I did that, identify your A, B, and C. Write A times C on the top, which is -10, because 1 times -10. Your lowercase b at the bottom, which is 3. Two numbers that multiply to -10, but add up to 3. 5 and -2, correct? 5 times -2 is -10. 5 plus -2 is 3. Looks good. So now, replacing the middle term, you get 5x minus 2x, but then this is a positive 5x. And don't forget your x squared that's in front, and then -10 in the back. So this is equal to that expression now. Factor by grouping. Pull out an x from the first term, so leaving me with x plus 5. And then there's a negative sign, so I'm going to put minus 2x and 10. The GCF between those two is 2, leaving me with an x plus 5 inside it there. And you can see, using GCF, that between these two terms, x plus 5 is what they have in common, leaving you with an x minus 2 in this particular case. Now, when you do your work, if you did things correctly and you're writing your math correct, sometimes you'll notice that this and this may not be the same. So that means either you messed up already somewhere, or you may not have done the GCF, factor by grouping, properly. And that would stop you from going to the next step. Okay, but because the GCF is x plus 5 for both terms, we are good. Now, as a final bonus question that you should understand from this, besides the basics, is number 7. I'll put a big star here. We get 2x squared plus 12x plus 18. Now, when you see something like this, notice that you still have 3 terms like before, and your A is 2, your B is 12, and C is 18. Now you can go ahead and start factoring it. But the number one thing that you should do first, I'm going to put a big star here, is pay attention to the fact that the GCF from all three terms. See if there's anything like that. Find GCF first. And if you do that, the GCF is 2. Because if you look at 2x squared 12x and 18, they all are divisible by 2, leaving me with x squared plus 6x plus 3. So this is equal to that. Now, because of this, I will now refocus on factoring just this trinomial here, where the a is 1, b is 6, and the c is 3, just like we've done before. And so, doing my work on the side here, a times c is 3, b is 6, two numbers that multiply to 3. Oh, why did I write that? This doesn't seem to work, because I can't think of any two numbers that multiply to 3 but add up to 6. Instead, I'm going to go back and hope that I made a mistake so that I could fix this, and I did, which is this part right here. When I took the GCF, it should be x squared plus 6x plus 9. So then it really should be 9 here for my c. So then there should be a times c is 9. There we go. Now with that being said, what two numbers multiply to 9 but add up to 3? 1 and 9, 3 and 3. Oh, 3 and 3. 3 and 3. Those two positive numbers multiply to 9 and they add up to positive 6. So that's going to replace this middle term there. So that plus 6x is really plus 3x plus 3x. You still have the plus 9 and the x squared in front. Don't forget your parentheses and the 2 that's already there. Okay? Then I'm going to factor by grouping in this particular part. So when I factor by grouping here, I'm left with an x times x plus 3. There's a plus sign here, so I'll put plus. And what's the GCF between 3x and 9? Well, that's 3, leaving me with x plus 3. And then the red parentheses is right here with the 2 in the front. Again, and then what's the GCF between the stuff in the black terms? Well, that's x plus 3, leaving me with an x from the first term, and then a 3 from this term, so plus 3. And don't forget the red parentheses and the 2. And that red parentheses is just to help remind ourselves that it's 2 times all that stuff. So I could really drop the red parentheses. So then it's just, oh, sorry. It likes to do that once in a while. Let me see if I can scroll back. There we go. It likes to remind us that it's 2 times all of that. So it's still the same thing as 2 times x plus 3 times x plus 3. But if you know that x plus 3 times x plus 3, wouldn't you agree that we can write it using exponents as x plus 3 squared instead? So there's your factored forms. Okay? And the reason why I chose this method to show you is that even if your leading coefficient is not 1, you can use this technique of factor by grouping style for all your expressions essentially. But remember, the big thing is to find the GCF first to make your numbers a lot smaller. Otherwise, you're going to be dealing with big numbers when you get to this step right here. Okay? And that is it.